Alright, this video is all about compound probability. Alright, compound probability involves two or more events that are happening, and maybe you want to know the probability that both of those events will happen at the same time, or maybe you want to know what's the probability that one event or the other happens, or a variety of other things. But compound probability means you have more than one event that you're looking at. So problem number one. Suppose that you select a person at random from your school. Are these pairs of events mutually exclusive? Alright, so in this case the school would be what we call the sample space or the universal set. Okay, because the school is representing all of the possible outcomes. So this is the sample space. Okay, or the universal set. Anyway, are the events mutually exclusive? Alright, now let's talk about mutually exclusive. If you're looking at a Venn diagram, okay, if this is event A and this is event B, these two events will be mutually exclusive if they have no overlap, okay? If they have nothing in common. So, for example, if we were talking about boys and girls, there's not a student that you could pick that would be a boy and a girl. You're either one or the other. So an event like that would be mutually exclusive. If we were talking about animals, you could be a cat or a dog, but you can't be a cog. Alright, there's no hybrid cat dog. So having a cat or having a dog, those would be mutually exclusive. So mutually exclusive, two events that cannot occur at the same time. Okay, so event A, a person has ridden a roller coaster. Event B, a person has ridden a Ferris wheel. Is this mutually exclusive? No, this is not mutually exclusive. You could have a person that rode a roller coaster and rode a Ferris wheel. So it's not one or the other. How about brown hair, brown eyes? Is that mutually exclusive? No. You could have a person that has brown hair and brown eyes. So those are not mutually exclusive. Okay. How about left-handed and right-handed? Yes, those are mutually exclusive. You're either left-handed or you're right-handed. Or there's something called ambidextrous, but that's not one of the options. So you can't be left-handed and right-handed. If you could use your left hand really well and your right hand really well, you're called ambidextrous, but you wouldn't be called left-handed and you wouldn't be called right-handed. So these are mutually exclusive. For D, owns a classical music CD, owns a jazz music CD. These are not mutually exclusive. Because you could have one person that owns a classical music CD and a jazz music CD. It doesn't have to be one or the other. Okay, a person is a senior, a person is a junior. These are mutually exclusive. Alright, you're either a senior or you're a junior, or you could be a freshman or a sophomore, but you can't be a senior and a junior at the same time. Those two, you can't be both. So those are mutually exclusive. Okay. Has shoulder length hair, is male. These are definitely not mutually exclusive. Alright? You can be a male that has shoulder length hair. It could be very lovely, well conditioned, shiny, and awesome. So yeah, you could be a male with shoulder length hair, no problem. I see it all the time. Okay, so that's the end of problem number 1. Hopefully you understand that this diagram represents two events that would be mutually exclusive, whereas this diagram represents two events that would be overlapping. Okay, anyways, let's look at number 2. A group of senior citizens have won free vacation packages. The vacation to Bermuda is chosen by 25% of them. 60% choose Alaska. 15% choose Costa Rica. What is the probability that one randomly chosen senior citizen chooses to vacation in Bermuda or Costa Rica? All right, now look at these percentages. 25% plus 60%. All right, 25 plus 60%. So far, that's 85%, right? And then plus 15%. So guess what? That's 100%. All right, so the 25, the 60, the 15, that's all of the people. Everyone chose one of these things, all right? So that means there's no overlapping going on, all right? So they either chose Bermuda or Alaska or Costa Rica, all right? So if we were looking at a Venn diagram of these situations, we would have 3 completely separate circles. Okay, let's see. Will the letters work for me? So we'll call this one B for Bermuda, and A for Alaska, and C for Costa Rica. There's no overlap, all right? So these are mutually exclusive. So let's see. Let's get these probabilities in there. So, all right, Bermuda, that's so 25% of them chose Bermuda, 60% for Alaska, and 15% for Costa Rica. Okay, if I want to know the probability that a randomly chosen senior citizen chooses Bermuda or Costa Rica, all right, so I'm talking about the probability of event B or event C. Okay, or another way I could have written that, this meaning the same thing, is event B union event C. Both of these, or and union, they mean the same thing. When there's no overlap to worry about, all you have to do is add. Okay, so both of these are going to equal the probability of event B plus the probability of event C. All right, you just add up the two separate probabilities, and then that will be the total probability of being one or the other. Okay, so in this case, that's just going to be 25% plus 15%. Okay, so that's 40%. All right, so that's the answer. We often express this as a decimal, so understand that this would be the same thing as 0.4. Okay, good to know. All right, moving on to number 3. Use the general addition rule, which is what we were just doing up there, to compute the probability that if you roll 2 6-sided dice, and then we have these situations down here. So let's start by setting up a table for ourselves. Along the top here, this represents the possible outcomes of rolling the first die. this six-sided number cube. It could either be a 1, a 2, a 3, a 4, a 5, or a 6. And down the left side, this represents the other. All right, we're talking about 2 dice. So this is the other die and its possible outcomes. Okay. Now we're dealing in sums. All right, sum. So we're talking about addition. So let's make a table of the sums of these outcomes. So for example, I'll just randomly pick one. Let's say the first die over here you rolled a 3, and then on the other die you rolled a 4. Okay, so that would be this square right here. What would be the sum? It would be 7. Alright, if you rolled a 3 on one and a 4 on the other, that would be 7. Okay, what about this element right here? Okay, this would be a sum of 4. Alright, 2 plus 2. In fact, first for fun, I'll just do all the diagonals now. Alright, I've got 1 plus 1, and then we just did 2 and 2, 3 plus 3. Alright, 4 and 4 make 8. You could have a 5 and a 5 to be 10. 6 and 6 make 12. Okay, let's see. For example, what about this one right here? A 5 and a 1 would make 6. So I'm not going to sit here and do every single one of these squares on the video. If you get the idea, go ahead and just pause the video and finish completing the chart on your own. I'm going to do it off camera. Alright, fun patterns here to look at. When you are completing this table in the future, notice the diagonals. Okay, the diagonals going this way. See how we have 3s and 4s and 5s, and really we started with 2. So it's 2, 3, 4, 5, 6s, 7s, 8s, 9s, 10s, 11, and then 12. So it starts with 2 in the upper left hand corner and ends in 12, and along the diagonals it's just counting up 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So if you're doing this in the future, it would be really quick to make this chart. Okay, if you recognize the patterns. Now, back to business. For part A, we have a compound event. We're supposed to find the probability that you get an odd sum or a sum greater than 10. Alright, so that's 2 separate events. So we'll call the first one event A. Okay, so we have the first event is getting an odd sum. Alright, I'll call that A. And then we have event B is a sum greater than 10. Okay, so we want to find the probability of event A or B happening. So in other words, you could write it this way. We want the probability of A or B, which is the same thing as writing the probability of A union B. Okay, and for both of these, we are going to calculate these probabilities. Now, there are a couple of different ways to think about it. Let's go back to basics. In general, when you're calculating the probability, I like to think of it as target over total. Okay, the thing that we're shooting for divided by the total number of possible outcomes. Okay, so in this case, we have made a chart of the entire sample space. Alright, this is the universal set. So, how many possible outcomes are there? Well, we don't have to count each one of these to see how many there are. We can see that there are 6 columns and there are 6 rows. So 6 times 6 is 36. So without counting all of these, we know that there are 36 total possibilities. Okay, so whatever else happens, we're going to divide by that total of 36. Now, let's look at the target. The targets, we want it to either be an odd sum or a greater than 10. Either one of those will be fine. So let's just go ahead and highlight everything that fits either one of those criteria. It doesn't have to be both. That would be an and. It just has to be one or the other. All right. If it happens to be both, great. That, we don't care. So let's start with odd sum. So these are all sums. So so here's an odd. Those are odd. These are odd. These sums are odd. Okay, more odd. And these are also odd. Okay? So, is there anything else? Okay? So these are all the odd ones. But we also are allowed to pick ones that are greater than 10. See, let me pick a different color. Okay, so greater than 10. Well, these two are greater than 10, but we already got them. So there's only one more, okay, that's greater than 10 that we don't already have, and that's 12. Okay, so we need to add that in. So now all of the ones that we have highlighted are the targets. So how many of those do we have? Well, we could just count them all up. Okay, but obviously that would be the long way. All right, if you notice that in each one of these columns, for example, there are a total of 6 possibilities, and half of them are odd. 3, 5, 7, 3, 5, 7, 5, 7, 9. 5, 7, 9, 7, 9, 11, 7, 9, 11. So the yellow ones are exactly half of the set. So half of 36 is 18. So we have 18 yellow ones. Okay, I don't know if you can see this color. I'm trying to make it sort of yellow. All right, so we have 18 yellow ones, and then plus the one extra green one that we had to throw in as well to get the one that was being left out that was greater than 10. So that's a total of 19. Okay, so that's why the probability is going to be 19 out of 36. Okay, this is one way to think about it. And we could express that as a decimal. Alright, by doing 19 divided by 36. Alright, so that is 0.52, and let's use 4 decimal places. So 0.5278. I'm kind of running out of space here. So 0.527, and we'll round the last one up to 8 because the next one is a 7. Alright, so we could express that as a decimal. Alright, of course we could have also written that as a percent. Alright, this would be 52.78%. Squeezing it in. So there's 3 different ways of writing this answer. Either one is good. Alright, so that's part A. Now let's go ahead and talk about part B now. Okay, before we go on to part B, I want to show you the other way we could have thought about part A. We could have done the formula. In this case, the two events, odd sum, okay, remember event A, and sum greater than 10, okay, we called that event B. These two events are not mutually exclusive. They are overlapping. Okay, so if we looked at a Venn diagram of A and B, you could have numbers that were odd sums, okay, like 9, and you could have numbers that are greater than 10 that are not odd sums, like 12, but we could also have overlap. Okay, we could have an odd sum that is greater than 10. Okay, we had 2 of those. Okay, we had 11 that showed up twice. Okay, so let's count up like how many of those there were, or maybe not. Maybe I won't do it that way. Maybe I will. Okay, so here's the deal. How many numbers were in this overlapping part? Okay, this overlapping part. This is where you're an odd sum and at the same time you're greater than 10. Okay, so these 11s right here, these are the only odd sums that were greater than 10. So there were 2 of those. So I'm putting 2 to represent that's how many outcomes there were. Okay, now let's talk about odd sums. All right, half of these were odd, remember? So that was 18. So I could put a 16 right here for the rest of the odd sums. We've already got 2, so I'll put a 16 for a total of 18. So that's the half. Okay, now anyway, this event over here, sum greater than 10. How many of those did we have? Greater than 10. Well, we had these 3, 11, 11, and 12. We had 3. So we already have 2 of them in the intersection. So that means there's 1 outcome that's out here. And that was the 12. That represents the 12. Okay? So this is a Venn diagram of what's happening. But look at how they overlap. So here was the formula for finding the union. If I want to find the probability of A or B, okay, which is the same thing as the probability of A union B, okay, both of those mean the same thing. So if I want to find that when it's overlapping like this, what I have to do is I can do the probability of A plus the probability of B. Okay, but I have to subtract something because of this overlapping part. If I do the probability of A, okay, I'm counting the 16 outcomes and the 2 because they're all in A. Okay, so in fact maybe I can just go ahead and write that down. That's 18 out of a total of 36. All right, total outcomes. Now, if I look at the probability of B, okay, well, see, B is this circle right here. How many of those are there? Well, there are 3. Okay, the 2 and the 1. So that would be 3 over 36. But there's a problem. When it's overlapping, you wind up counting the overlapping part twice. We got this 18 by going, oh, we had 16 and 2. And then we got this 3 by going, oh, we got this 1 and this 2. So the 2 got added in twice. It's being double counted. There's only 2 of them, not 4. You can't count it twice. So you can compensate by subtracting the extra overlapping part. So in other words, subtract the intersection. All right, subtract A intersection B. Okay, so in this case, we will subtract the overlapping part, which was 2 over 36. Okay, so anytime you have overlapping, if you want to find the probability of one event or the other, okay, the union, all you have to do is find the probability of one, the probability of the other, and subtract the overlapping part. So 18 plus 3, that's 21. And then minus 2 is 19. So you are still going to get 19 out of 36, just like we did before. Okay, so you'll wind up getting all the same answers. But this is, I just wanted to show you the formula. You know, I think the easiest way is to do it like I did it before, and showing it this way is more complicated. But there will be times that we have to use this formula, though there will be no way around it. So even though it's a little confusing, I wanted to expose you to it. Alright, so I hope you understood at least half of that. Anyway, let's get back to part B. How about the probability that you get an even sum or a sum of 11? Okay, so these are the two events, even sum or the sum of 11. Okay. So, you know, so an even sum, how do we want to do this? If we look at the even sums, those are all of these, just like we did before, okay? The 2, the 4, the 6. Maybe I should do it on the diagonals. All right, the 2, the 4, the 6s, the 8s, the 10s, and the 12. So once again, that's half. Half of the outcomes have even sums. All right, so I know that so far these yellow ones, that's half of my 36, so that's 18. So again, one way to look at it, right, if I want the probability of event A, and again I'll call this event A and I'll call this event B. So if I want the probability of A or B, okay, and that's the same thing as A union B. It still comes down to target over total. So there's still 36 total outcomes possible. So that's going to be 36. So it's a matter of counting up all of my targets. So far I've got 18 because that's from the A. Alright, all the even ones. Now, how about sum of 11? Well, okay, I'm going to add in these green ones, okay? So it could be, these would also be what we wanted. So I'll have to add in 2 more of those. Okay, so obviously that is a total of 20. So that's going to be 20 over 36. Let's remember how to reduce that. If we just put it in fraction mode, 20 over 36, the calculator will reduce it for us. Okay, 5/9. Okay, so as a fraction, that would be the probability. Now, if you did not have a calculator, or if you wanted to use your brain, you could recognize that both of these are divisible by 4. So divide by 4, divide by 4. That's 5/9. Okay, so that's going to be the answer. We could express this as a decimal. All right, 0.5556, got to round up. 0.5556. And we could also write that as a percentage. That's weird. As a percentage, we would write 55.56. Okay, so these are the answers. Now remember on the last problem when we looked at the formula, how anytime we had an overlapping events, we could find the union by adding the probability of each event and subtracting the overlap, subtracting the intersection. So those were overlapping events. Notice that these two events are not overlapping, all right? Or we could say they are mutually exclusive, remember? So Venn diagram, non-overlapping. And because think about it, if you can either be an even sum or you can be a sum of 11. There's no way you can be an even sum that's also 11. It's one or the other. So so remember, when you have mutually exclusive events, okay, when your event A and your event B are non-overlapping, then you can just add. Okay, you can just straight add. The probability of A or B is just going to be the probability of A plus the probability of B. Alright, you don't have to subtract anything because there's no overlap to subtract. So, the probability of A, okay, that was the even part. Alright, the probability of being even. Remember how that was half, alright, half of them are even, so that was 18 over 36. And then the probability of being a sum of 11. Well, there was two of those, alright, so that was 2 over 36 would be the probability of event B. Okay, and of course, 18 36ths plus 2 36ths is 20 36ths, and we'd get the same thing that we had before. Alright, so I just wanted to connect it up with the formulas once again. Alright, this video is getting long, so let's go ahead and call that the end of part 1, and we'll do the rest of this lesson as another video, part 2. So go look for that.